Instructor Andrea here with another addressing video. This time we're going to be talking about Boolean. Boolean is used in networking, specifically to find the network address. You may have heard the term Boolean before, especially if you've taken like a programming class like Python. Boolean is a type of math that uses only two values and makes a comparison. A lot of times engineers are using it, programming is using it. I've even seen it used when people are writing poems. In computer networking, we use Boolean logic, specifically the AND operation, to compare two values and come up with an outcome. In networking, we're using the AND function, specifically ones and zeros, binary. We know that binary only has two values, ones and zeros. And we've learned how to convert IPv4 addresses into their binary equivalent, or from decimal to binary. And then also we've looked at subnet masks and how to convert subnet masks to their binary equivalent, ones and zeros. We convert those, and then what we can do is use the AND function of Boolean to actually figure out the network address. The AND rule is simple. We have two values and we compare them. For our purposes, we're going to compare binary values. As an example, 1 and 1. So we compare 1 to another 1. And the outcome is 1. All others are 0. Everything else is a 0. Here's the example. 1 and 0 is 0. 0 and 0 is 0. That's how simple Boolean is. Using the AND rule, I'm going to apply it to some bits so we can see this. Here, I've got my first set of values in binary, and I'm going to compare it or do an AND function with another set of bits. If I've got all ones and I compare it to all ones, I end up with all ones. That's simple rule. If I have all zeros and I compare them, I have all zeros. A 0 and a 0 is a 0. A 0 and a 0 is a 0. If I compare a 1 and a 0, that is a 0. Remember, the only thing that leads to a 1 is a 1 and a 1. Now we're going to compare 1 0 1 0 to 0 0 1 0. My outcome is going to be 0 0 1 0. If we look at these 8 bits, I'm comparing a 1 and a 1, I get a 1. A 1 and a 1, I get a 1. And when I do 0 and a 0, I've got a 0, etc. Until I get back down here to my very last bit in my octet, and I've got a 1. Let's take a look at one more. Notice here, all of the ones are on in this second value. That means the 1 and a 1 is a 1, a 0 and a 1 is a 0. Because all of the ones are on, this number is going to be exactly the same. And this is what we're going to start looking at with the subnet mask. Now, why Boolean matters is because we will use Boolean logic to figure out and find a network address. We need to know network addresses as network administrators because the routers and devices will need to know how to figure out whether the network they're on is local or if it's a remote network. It's a key part of networks being able to communicate with each other. We're going to take a look at an example of how to find a network address. In previous videos, we learned how to convert IPv4 to binary and the subnet masks to binary. We need to do that. I'm going to open up my command prompt. Looking at my command prompt, I can see what my IPv4 address is, I can see what my subnet mask is, and I can see what my default gateway is. But notice it doesn't specifically tell us what my network address is. And that's okay, because the host device can figure that out for itself by doing a Boolean logic of its IPv4 address to the subnet mask. The first thing we have to do is convert the IPv4 address to its binary equivalent, convert the subnet mask to its binary equivalent. I've done that here. Remember, a 1 and a 1 is a 1. Everything else is a 0. Here's my IPv4 address, 192.168.0.76, and I have bit that out. Here's my subnet mask, and I've bit that out, 255.255.255.0. Now what I can do is Boolean logic to determine what the network address is. A 1 and a 1 is a 1. A 1 and a 1 is a 1. A 0 and a 1 is a 0, right? So here's my outcome. And this tells me what my network address is. And I can see that it's 192.168.0.0. This is my subnet mask. And we've learned from past videos that the subnet mask determines which bits in this IP address are part of the network. Well, I can do that by masking the address, or I can do Boolean. There's two ways for us to figure it out. The logic that our end devices and our intermediary devices use is Boolean. That's it. That's Boolean logic for network addressing bit by bit. ANDing helps us find the network address, which, by the way, is the next video in this series of videos. I hope this helps and gives you some additional addressing tools.